In problem number 11, we have a problem where we have to read the graph of a derivative. So the graph that's given on the problem represents the rate of change, w prime. So what we're looking at here is a graph of the derivative. So it's very important to get that solid because there's a lot of questions like this on the test where you're looking at a graph, but the graph you're looking at is the derivative. So you have to consider what that means. You're not looking at the function here. You're looking at, this is graphing the rate of change. So in whatever unit this is, for example, at time 0, because time is our x-axis here, our rate of change is 4. So it's increasing at a rate of 4 something. 4 per whatever. And as time goes on, this line is measuring the rate of change at any point, not the actual amount of werewolves. So A says estimate the net change in population over the first 7 years. So this is a question that's asking us, though, about the actual amount. How much did the amount change? Well, if we have a derivative of something and we want to get the actual amount, that means we need to take the antiderivative. And if we're looking at the net change, that would just mean the area under the curve. Positive parts are positive, and we take away the negative parts. So essentially, part A is saying, what is the definite integral from over the first 7 years? So from 0 to 7. Of w prime of t. That is what problem A is asking us. Now, obviously, we don't have a function, but we have the graph, so that's how we're going to have to do this. And if we want to get this definite integral, we just need to consider the area under the curve. So we have this part here and this part here that are positive, and then we have this part down here that's negative. So we're just going to add up the positive parts and take away the negative part. So this part right here is a triangle. It has a base of 2 and a height of 4. So the area of it would be 2 times 4 times a half, which is 4. So that area is 4. Here we have half of a circle, and it has a radius of 2. So the area of this would be pi r squared divided by 2. And since our radius is 2, that would be 2 pi. And then remember, that's under the axis. Over here we have another triangle. This only has base and height of 1. So its area is 1 times a half, which is 1/2. So then our definite integral is going to be 4 plus 1/2 minus 2 pi. Because we're taking away the part that's under the axis, because we're just doing the definite integral here. So to get this as simple as possible, 4 is 8 over 2, plus 1/2 is 9 over 2. So we'd have 9 over 2 minus 2 pi. And that would be our estimate of our net change in population over the first 7 years. So part B asked us for what years after the first year and before the 7th year does the population reach a maximum or a minimum. So we need to find maxes or mins somewhere in this graph. So our population, our amount, would have a maximum or a minimum when our derivative was 0 or undefined. So we're looking at our derivative. So where is this 0? It's not undefined anywhere, first of all. But it's 0 right here and right here. So at these 2 points, we could have a max or a min. And we would know if it's a max because if it's a maximum, the function would be increasing on one side and then decreasing on the other. The amount would be increasing and then decreasing, which means that our derivative would be going from positive to negative. Of these 2 points, this first one here at t equals 2, that one fits that description because our derivative was positive before it and it's negative after it. So we have a max at t equals 2. The point here at t equals 6 fits the description of being a minimum, because remember, for a point to be a minimum, our amount has to be decreasing and then increasing, which means our derivative has to be negative and then goes to positive. This is negative and then it goes to positive. So this is a minimum. We have a min at t equals 6. So those are our 2 years after this starts. We have a max population. At 6 years down the road, we have a min population. So C asks us to make some sort of number line chart. So for W prime, that number line chart is going to be pretty basic. Keep in mind, these aren't really infinite things because they're only going from 0 to 7. That's the only information we have here. So to get our sign chart for W prime, we're just looking at this because this is W prime, remember? So it's 0 at 2 and 6. And it's positive before 2. It's negative in between 2 and 6, and it's positive after. So that's our sign chart for W prime. That's pretty basic. Our sign chart for W double prime might be a little bit more tricky. So we need to figure out where the second derivative would be positive or negative. Well, think about it like this. If the derivative of something is positive or negative, that means that that first function is increasing or decreasing. Remember, so if a function is increasing or decreasing, its derivative is then positive or negative. So if we want the second derivative to be positive or negative and figure out where that is, we need to know where the first derivative is increasing or decreasing. Because if the first derivative is increasing, its derivative, the second derivative, would be positive. And same thing with decreasing and negative. So we can answer this, or we can put numbers on that number line depending on where this is increasing or decreasing. We do have to be a little bit careful too, though, because if this is not differentiable at any point, that would have to stop this second derivative. So this function is not differentiable at these zeros because this is, essentially think of this as a piecewise function. The slopes of these two parts of the graph don't connect smoothly. The slope immediately jumps from something to something else. So this is not differentiable. So we have to put 2 and 6 still on the number line because it's not differentiable at those points. And the only other numbers we would need to put on this number line is where is this derivative 0? Where is the derivative of this graph 0? Well, that only happens right here at the bottom of that circle, because this is all decreasing, decreasing, decreasing. Now it's increasing, and it increases for the rest. So that happens at 4. So we have to put that on the number line also. So the second derivative would be positive or negative depending on whether this is increasing or decreasing. So from the 0 to 2 section, this is decreasing. So that would be a minus. On the 2 to 4 section, this is decreasing, so that would be a minus. On the further 2 sections, it's increasing and increasing. So that's what our sign charts would look like for W prime and W double prime. So then the last part of this question is we need to graph a possible W function. So we have the derivative in front of us already. Therefore, we have its sign chart. We just made a sign chart for the second derivative. So keep in mind when you have a graph of a derivative and you're trying to graph the original function from it, it's never a precise thing because an antiderivative, or a function has infinite antiderivatives, because it could be shifted up or down as much as you want and it wouldn't change what the derivative would look like. So keep in mind when we do this, this is not like a concrete thing. This is the only thing it could look like. It will just have the shape, but it could be anywhere vertically. So what we need to consider is from 0 to 2, it's increasing, and concave down. So I'll draw this one in green here. So let's just say we start here. I just picked any number, it really doesn't matter. So it's increasing and concave down. So let me get rid of these area markers so this will be more clear. Okay, so from 0 to 2, we're increasing and concave down. We become decreasing after that, so that means there's a max at 2. So I'll just put that point, let's say up here. So this graph will look like that. It's increasing, concave down. After that, it's still concave down, and now decreasing though. And at 4, the next upcoming point, we have an inflection point because our second derivative goes from negative to positive, so we switch concavity. So this is increasing concave down, and then right here, we have an inflection point. We switch back to being concave up. We're still decreasing though. And at 6, we hit a minimum. So here we're concave down, switch to being concave up, and then for the rest of the time, we're concave up and increasing. So that is one potential way this graph could look. So all I did was use these sign charts to pick out my increasing, my decreasing, concave up, and concave down.
The Teaching Center, UF's Learning Resource Center.